Okay, section 7.3 coming up. It won't take long. Decimals, yay. Okay, this section talks about repeating decimals. In class the other night, I went one way. I took a fraction to a repeating decimal. I'll do one of those, and then I'll do a couple going the other way, from a repeating decimal to a fraction. But first, here's a little review. So now we're working with decimals. And I hope when you look at this problem, you go, okay, 1 liter is 4.224 cups. How many liters is 36.4 cups? I hope you see a proportion here. I'm looking for liters. So I'm thinking X liters over 36.5 cups. Well, I know the 1 liter is in 4.224 cups. So all I have to do is do the cross multiplication. So my X number of liters is 36.5 over 4.224 cups. And we got $8.64. And it's liters because that's what the units on X was. Okay, does it make sense? Okay, I got 1 for 4 cups. I'm going up to 36. So it should be around 9. So, okay. Notice, I always use the units. Putting units in the problem is so important because when a student gets to physics, chemistry, and everything, they do unit analysis before they even put numbers into a problem. Okay, here's another one. So she ran 30 kilometers. We're looking for how many miles. So X is the miles in the 30-kilometer race. Hey, that's what I ran this morning. So there's 0.62 miles per 1 kilometer. So I'm just going to do that. So it's really just 30 times the 0.62 . 11.5, basically. Wait, that's not right. That's got to be 18. My calculator's off. Wow, my calculator won't hit a 0. There we go. $18.6. So here's how I caught my error. A kilometer is a little bit more than a mile. So I had better gotten, or a little bit more than half of a mile, I'm sorry. So I should have gotten a little more than 15, which is half of that. When I got 11, I knew something was off. Also, I looked at this. I looked at 6 times 3, should be around 18. But again, it was just a proportion. Okay, let's get to this section. We've done terminating. We're going to learn to take ones that don't terminate, and this doesn't because it's only an 11 in the factored form in the denominator. So I know it doesn't terminate. We talked about the repetent, the part that does repeat. So if I had 0.6832, that tells me that after the 6 and the 8, the 3, 2 is repeating. So we're going to do long division. I think I did something with sevenths in class the other night. I'm going to do this one. And I do know this. The repetent could have up to 12 digits. I'm really hoping it doesn't, because that would be a really long division problem. I know that because it's 13 subtract 1. It's always one less than the denominator. If you do this one on yourself, it will have 6 digits in the repetent. Okay, so we have to do this. 13 is being divided into 2. Okay, it doesn't go one time, but it does go 1 into the 20. And now I'm thinking of how many 13s going to 70. Oh, there's 5 of those, because that's 65. Now I got a 5 and a 0. Not quite 4 of those, because that would be 52, so there's only 3. That's 11. Bring down to 0. Now how many 13s into 110? Well, 10 would be 130. So 9 would be the 13 last 117. It's going to be 8 of those. That's 104. But fix my little 8. Oop, that's not what I wanted. Okay, that's an 8. Okay, we subtract. Now we're down to 60 because it's not 5. There's going to be 4 of them. That's 52. Now we're down to 13 into 80. That's 6. Oh no. I just hit erase. I don't want that. Okay, so now we're at 80. There's a 6 here, because that's 78. We subtract. Oh, yay. That's where we started. That's our first repeating dividend. So I've got it. I know my repetent. It's 0.153846. And don't forget to put the line over it. So that's how we go from fraction to decimal. Long division. How do we do this? This is kind of a neat little technique. There's some algebra involved here. So notice it's the 5 that's repeating. So I'm going to make x equal to 0.5. Now, this is going to be strange. I'm going to multiply by 10, and that's going to get 5.5. Notice it's still the 5's repeating. I did this to match up after the decimal, the repetent. Because now I'm going to do this neat subtraction trick. I'm going to take 10x and I'm going to subtract x. So I'm taking the 5.5 with the repetent, and I'm subtracting basically that repetent. So over here I get 9x. This is why you line up the repetent with the decimal, because when I subtract that, it's gone. So 9x equals 5. I'm going to solve for x. It's 5 over 9. Hit that on your calculator, and you get 0.5 repeating. We'll do more examples in class, but I'm going to do another one here. Ooh, apparently I lost that slide. Okay, let's do one where the repetent is not directly after the decimal. Let's do a 3.46. Ooh, let's not put the 7 in there yet. Okay, let's do this. Well, I'm going to start here where x is this. Now what I want to do is get the repetent right after the decimal point, because that's still going to be a string of 6s over here. So I'm going to multiply by 100. Because I move the decimal 2 places. So I get 3, 4, 6, and then after that is a string of the 6s. Now, this is important. I can't subtract by x. If I just put x in there, I get 3.46. I'm not lined up. I can't subtract and get rid of this repetent. So I have to do it differently. To line it up, I'm going to have to move that decimal point once. I need 10x to get 34.6. So when I subtract, I have 90x. Okay, the repetent is gone. 346 subtract 34 is 312. X is 312 over 90. Try that on your calculator. And I got my 3.46666, which is what we started with. Magic, right? I'll see you in class soon.